All right, y'all. Good afternoon. Um, Today we're going to be looking at solving square root equations. So I'm going to kind of go through the basic steps for it, and then I'm obviously give you some examples on in different scenarios to kind of go with it. You definitely will need a calculator, and excuse me. All right, so here we go. So first thing I'm going to kind of talk about is this particular equation, which hopefully looks familiar to you if you remember about doing transformations and such. Now, the difference between this and the one you probably have seen before is the way it's written on the under the radical sign here. So the first thing I'm going to tell you is this sign, if you're not familiar with this sign, that particular function itself is called the radical sign, okay? And it's used for roots, cubes, square roots, things of that nature, okay? So the basic steps, and again, I say basic is because some pieces may be missing. So if it's not there, you don't actually go through it. But normally, the first thing you always want to do is move your k value by adding, subtracting. And so everything we're doing here is going to be an inverse operation, okay, to start off with. And so when I say move the k value, you're either going to be adding or subtracting the k value, just depending on what the starting sign actually is, okay? Then you're going to do the a value, which is this a value up here. And in that case, you're going either to multiply or divide depending on the actual sign, okay? Once that's cleared out, then the next thing that's going to end up happening is you're going to be having to square both sides. Now, in this case, because we're doing square roots, the only thing we have to worry about doing is squaring both sides, but depending on what the root value is determines what you actually raise the power. So I like to kind of use the term power up to kind of reference this particular step, because that's essentially what I'm going to do. Is I'm going to be taking this side in this case and squaring both sides to power up to squared, in order to be able to solve what I want to actually do, okay? Then you end up with the actual radical sign. So we're going to clear the rest of the radical sign, okay, by moving the h value next. And again, that would be either by adding or subtracting. And then if you have a b value in front of the x here, we're going to either multiply or divide again, depending on what that b value is. And at that point, you should have a solution. Once that's done, then we're going to do something called checking for extraneous solutions. And if you don't remember what extraneous solution is, okay, essentially it's a solution that produces, or let's just put it this way, extraneous solution essentially is a solution that doesn't actually work, okay? And it could be for different reasons. And the best way to describe it is it doesn't validate the equation. It doesn't make a true equation. Again, I can say different ways, but basically it's just not going to work. And you'll see that in a second. Input doesn't validate equation. So you kind of maybe get a different idea as to why it doesn't work. Okay. But anyway, so that's the basic steps for it. And I'm going to go through some examples, different scenarios, and we'll go from that point on. Okay. So first thing I'm going to tell you is this. This value here, which would be a y value in this case, can be written on either side of the equation. It's wanting to focus here. Let me move my camera. Kind of give you better. Maybe that'll work a bit better. Yeah, perfect. So it may not always be written in this format. It may be that this is equal to 8 instead on this side. The process doesn't change in how you work through it. Okay. So I'm going to go through one to kind of show you. So I'm going to clear the radical sign out first. Okay, that means that this and these two values are going to have to get moved. So I'm going to move my k value first by subtracting 4 to both sides. Okay, and I'm going to draw my line here to kind of help you keep things in order. And so that way that gives you that equation. Then I'm going to divide by 2 here to both sides. And again, that'll give me the equation. Okay, so now I have my radical sum by itself. Now I'm going to power up by squaring both sides. So that'll give me 4 is equal to, and when that happens, your square cancels your square root because they're inverses of each other. So all you're left with is just the information underneath the radical sign. Okay. Then I would add 2 to both sides, and what I would get is a solution of 6. Okay. So what I want to do is make sure that that answer actually works. And what you do is you take that answer, you go back to your original equation, and you plug it in for the x value in this case to see, does it validate the equation? And I'm going to use my trusty calculator in this case to do this. But essentially, I just want to figure out, there's 2 to the square root, 2 times the square root of 6 minus 2 plus 4 equal 8. And it actually does. So this is true. So then this is a good solution. Okay. Now, what would have happened if the solution you had did not work? Well, then we call that extraneous. Okay. And again, I will get to a point where you will see one of those. Okay. But if you want to try do what I just did on example 2, go for it. Let me fix my camera here. There you go. I'll pause it and I'll come back with the solution here in a second. All right, folks. So again, subtract your 6. And because this is a 1/2, I multiply by 2 instead to both sides. Okay, that way this value becomes a 1. Then I power up by squaring both sides in this case to get a 36. Then I clear the information under the radical, divided by 3 to get 12. So x is 12. So here's, if I go back to check it, okay, and I plug it in for x here, the 12 that I just got, this is what happens. I want you to show you this. You get 9, okay? So 3 is equal to 9, which, again, does not work. And since that happens, then this solution here itself is what we call extraneous, okay? Therefore, there actually is no solution on this particular problem, okay? So there is no place where this equation is equal to 3, okay? So there you have that. All right. So the next set of problems, similar process, but basically this is what happens when you end up with radicals on both sides, in this case like this, okay? Now, there are different scenarios for these. This is kind of the basic one. Let me fix my camera again. That way I can stop going in and out and focusing, which for some apparent reason wants to do this now all of a sudden. Let me chance to let it focus. Okay, hold on. This is better. Okay, so here's what happens. You have 2 square roots on both sides, okay? Now, again, there are different scenarios for this, and where you may not have a value in front like this right here, and where you do. So I'm going to work about the ones that are where the value is in front of a radical like this, because if you don't have it, you follow the same steps just without having to worry about this piece, okay? So here's kind of the thing. Whenever this happens, yes, you could still have a k value and move it, but that would actually not work the way we want it to work, and what you're used to right now. So basically, we're going to focus on without the k values in this case. But we skipped that first part basically, and because even though we have an a value, which is what this is, even if we divided by 2, it's not going to actually do anything. So what we're going to do in this case is we're going to jump straight to powering up both sides. And what will happen is the square roots and the squares are inverses, so they'll become 1 and go away. So this 2 has to apply to this 2 here and make it 4. And then everything under your radical sign kind of just falls into place. Okay. So now you have a basic straight up linear equation instead. Now in this case, I do have to distribute my 4 through first, 48, before I can actually start working it through. But once I have that, then, I'm just going to do some, where if I, again, depending on how you want to do this, if I subtract 8 to both sides, make sure you subtract it to the right piece. If I add 48, actually make sure 4 times 12 is 48 because my brain's not working right now sometimes. 48 like this. So that when you get this, you get, what is this? 40 minus 8 is 32. That's equal to 50R. Okay. Divided by 50. So I have 32 over 50, which if you wanted to reduce that, you could. I'm going to say we're going to work some decimal numbers here. And if I divide that, you get 0.64 equals R. If I wanted to reduce it, I believe it comes out to be 16 over 25. Or 16 over 25. And I'm going to tell you this. The reason why you want a fraction is because you want to avoid irrational numbers if possible. And if you don't remember what an irrational number is, essentially if I had a number that, I'm not going to use that number, I'm not sure where that one came from, but if I had a number that was, 0.274678912, I could keep going on and on and on. That's an irrational number, which means it's not, you could round it, but it's not going to be accurate. Okay. So that's where fractions really come in to help, because when I check it to make sure that this answer works, I want to make sure that the answer I use is as exact as possible. Okay. I don't want to use irrational numbers. So if I did this, then I would do, 2 square root of 10 minus 12 times, in this case, 0.64. Oops, let me erase that. That's kind of ugly. 0.64. Okay, as my first one. And then I'm going to do the other one where it's the square root of 2 times 0.64 plus 8 to see, do these give me the same answers? So again, if I do 2 square root of 10 minus 12 times 0.64, okay, that would give me 3. That's ugly. But anyway, and then if I do the second one, you know what I'm going to do? I'm going to do it with a fraction instead, just so you can kind of see. Where it's 2 times 16 over 25 plus 8. And you get the same answers. So these are good answers. Either one of these would work. Okay. But I just want to show you that making sure that your decimal is a solid terminating decimal. If not, use a fraction to get the answer that you need. Okay. So here's another one. Try it again. See what happens. I'll pause it. Come back here in a second. All right, folks. So here it is. Now, first of all, I apologize. This is supposed to be an X, not a K. That was just a typo on my part. So they're both X's. You won't see anything like that. I mean, I'm not gonna lie. You could see stuff like this, just not this year, just not in this class right now. Okay. I work it through again. I part both sides. Make sure that 4 becomes a 16. Okay. Distribute the 16 to where it's 16x minus 48. That's just coincidence. Add 48 to this side. Subtract x from this side. So I get 15x and 39. Divide by 15, and I get either 2.6, or I can leave it as 39 over 15. Okay. Either way. So I go back to validate. And this is what happens. When I do 2.6 minus 9 square root, you get a non-real answer. So off the bat, because this happens on one of them, that means that this is actually extraneous again. And so this whole thing is a no solution. Okay. So that does happen. All right.